Hi everyone, let's get started. I think it's now 11:05, so let's get moving. Welcome to the Automated Manufacturing webinar. Thank you very much for joining us. Much appreciate your attendance. So today we'll be talking about automating manufacturing workflows, and the two presenters are myself, Jay, and Michael. And Michael, please turn on your screen. So the agenda for today, we'll be talking a little bit about who we are, just a quick introduction as to who I am, who Michael is, who Baynes is as a company. Then we'll be talking a little bit about the problems that are faced by manufacturers in the industry currently. So certain issues of delays in production or quality issues potentially, as well as other things that can happen when you've got return products and those sort of things, and how we're going to work through all of those issues. We're going to talk about a little bit about the current and older workflows, starting from a siloed position all the way up to the fully connected workflow. From there, we'll move on to the fusion workflow, so how one would actually go through the process of design and manufacturing working in the fusion environment. Then we'll talk about the Fusion Operations software package, which is an MES cloud-based software, which you will hear about and quite extensively about quite later on in the presentation, after which we will do a quick question and answer session, and then we'll close out. So who are we? Baynes. We are predominantly a digital transformation company. We service three areas. We do consulting, education, software, and hardware. Now, we cannot sell software or partner up with a software provider without the implementation of the software. So that's where the consulting comes in. And in terms of training and education, we teach the people teach the users how to use the software. We've got accredited classroom and virtual training. We've got a self-paced e-learning platform, which we've partnered up with Pinnacle Series to provide an online self-paced e-learning platform. We are an Autodesk authorized training center. We are also a gold partner when it comes to the software aspect of it. Now, for the most part, we are partnered up with ClearEdge, with Autodesk for the most part. Then we also partnered up with ClearEdge, Cool Orange, and Leica Systems. In terms of the consulting, we do BIM, data management, CAD/CAM simulation, as well as people, process, and business assessment. Predominantly, we find ourselves in the building, the civil, manufacturing, and the process plant environments, including mining. That is pretty much who Baynes is. We will now move on to who we are as presenters. Today's speakers is myself, Ajay. I am a mechanical engineer with some experience, quite extensive experience in the design and manufacturing side of the engineering field. I have worked as a designer. I've worked also as a project manager, as a project installations manager as well in the construction industry. I additionally have a postgraduate qualification in engineering management, which includes quality management and lean. Michael, who will be the person who's speaking for the most part today, has a degree in interior architecture, an honors degree, in fact, in interior architecture from the University of Pretoria, building on that with 9 years of experience in manufacturing of furniture, and then additionally 5 years or more of experience in CNC manufacturing, predominantly in 3 and 5 axis. With the strong foundation of educational background that he has, coupled with the practical knowledge that he's gained over the years, he is also able to assist with and create post-processing for CNC machines and the like. So without much further ado, let's get into the technical aspect of it. Let me quickly hand over to Michael, and he will take you through the rest of the presentation.
Thank you, AJ. Yeah, welcome everyone. Yeah, let's get started. So first, we're going to talk about what are the problems faced by manufacturers and what are the methods and some things we can use to alleviate these problems. So we're talking about the output of manufacturing facilities, and we want to see how can companies grow, what's stopping companies from growing. And growth is crucial for manufacturing businesses because it allows them to increase market share, generate higher revenue and profits, and invest in new technologies and create more jobs and enhance their competitive edge to become more resilient against the fluctuations and changes in the economy. And of course, this allows you then to solidify their position with the industry and contribute positively to the economy at large. Okay, so what is preventing this from happening? So we have this statistic here that currently over 70% of new products don't hit their profit targets. So what this means is, of course, is that the amount of profit that the new design is generating, the new product is generating, is not sufficiently exceeding the costs of production. And so there's several factors that affect this ability to achieve this profitability amount. So externally, there's pressure from customers and consumers for higher quality products. Customers may want to switch to another manufacturer if they feel that their product isn't meeting their expectations, especially as expectations are becoming higher with more competition from international manufacturers bringing in higher quality products for a cheaper price. And of course, inefficient manufacturing and design workflows can slow down the development of new products, which leads to higher overhead costs. The longer something takes to develop, the more iterations you need to do. The slower your process is, the more expensive it's going to be. So many manufacturers are still relying on outmoded and disconnected processes in their factories. Traditionally, factories are compartmentalized into like your managerial and operational departments, your drawing office, and then the factory floor, which has its own set of departments. Example, you might have a turning department, and you've got your milling department, assembly, quality control, you've got your goods receiving, your raw material receiving, and all of these, they have some sort of connection, but it might not be the most efficient form of connection. So in the past, these departments have only been connected by things like a physical printout, drawings and reports that are just on paper, and it becomes hard to analyze these quickly. It's hard to collect all of that data if it's just stacks of paper that are stored in boxes, perhaps, or attached to clipboards. So think of the time that might be spent or might be wasted trying to find a report on something like quality control on a part that finished its first production run like a month ago. You have to go and find where that's stored. You have to go and look through all the different results if you want to analyze that occurrence and see, okay, what happened there and how can we improve it when we're doing a run at a later stage. Slowing down, something like slowing down in quality control and trying to find out what was going wrong in a certain instance, that's an example of a bottleneck. What is a bottleneck? A bottleneck is a point of congestion in a production process that strangles material flow or production flow that then defines the output of the factory. So simply put, the output of a factory is defined by the output of its smallest bottleneck. So improving the bottleneck's efficiency should lead to an improvement in the factory's overall productivity and throughput. And all factories will have their bottlenecks somewhere. There will always be one machine or process that's going to take longer than the others and end up slowing down the overall production and throughput. And then without a centralized source of all your data, it's hard to see what's happening in the factory. It's hard to analyze exactly where these bottlenecks are. Things are slowing down somewhere, but maybe it's not so easy to see exactly where that is. And of course, it becomes hard to predict in future where there might be another bottleneck happening. Okay, so another major cause of bottlenecks is machine downtime. At the heart of our manufacturing environment is going to be machines, and the more advanced our manufacturing environments become, the more heavily we are relying on machines and automation. Everyone's pushing towards working at automation, and when machines work well, they work well, but if there's a problem, things slow down and your production is going from whatever pace it was to zero. So here's a quick list of things that cause machine downtime. Scheduled maintenance, so that always has to happen. If you don't maintain your machine, then you're going to have big breakdowns happening later down the line. But again, breakdowns, they may happen. And also if you want to upgrade your machine, you have to take your machine offline to improve it. And that's also going to slow down production. And of course, if we've got a new installation coming in and maybe other operations have to stop, they're going to stand still while we're bringing in a new machine. If these things aren't planned for, then the time taken up by these processes is going to be much greater, and things could be stopping in the process, in the production process, that might not necessarily have to be stopped if there was better planning. Okay, so what are the costs involved in not doing anything, in carrying on in the current process and not working to looking at more advanced ways of doing things, at having a more connected workflow? So we could have reduced profitability. We can have poor equipment effectiveness if we're not managing our machine maintenance if we're not using our machines to the best of their capabilities. There could be process inefficiencies, inconsistent quality. If we're not monitoring things well, if we're not like seeing exactly where the losses in quality are coming from, we're not going to have the best quality output of products. And then increased amounts of scrap is another possible side effect. If we, again, not tracking, we're not doing a good account of how much material is coming in and how much product is coming out. We don't have those easy accessible metrics to say, is the input matching the output, or is there a greater loss than we should expect on the output? Okay, so I'd like to run a quick poll quickly, and I'll bring that up now. So we want to look at what methods are you using to collect data and share it between your departments in your manufacturing environment. So we've got 4 options there. Is it paper? Is it digital? Is it a hybrid between the two? Or are we really working on the past and are we working verbally?
The gentleman's agreement.
Yeah. Okay, we'll give you guys a minute or so to think about that. Cool, so I see some results coming in, with a hybrid being the most common one. So still quite a few people still working in paper, and a couple of people working digitally. Okay, so it's good to see that there is some differing levels of advancement within people's workflows. Okay, so we've been talking about manufacture, but let's also talk about design and the translation between design and manufacture. Okay, so if we just think about design, and again, looking at a traditional way of doing things, you have an office of designers who receive a spec sheet from the sales team. Then the designer produces the design, submits that to management for review, and then once that's approved, it will be handed over to manufacturer for production. And conventionally, again, transfer of information might be done using paper printouts, just drawings, reports, and even just emails. And then changes that need to be made would have to go again through that same process. So it's paper printouts or just emails, which are also, everyone, if you're in management, you're going to receive hundreds of emails a day. It's hard to manage all of that information. So let's have a look at an example of a design that's going to be manufactured. So let's look at a sheet metal part. Yeah, we've got this design of a lamp, and you can see that the main body of the lamp is a part that will start as a sheet metal part that is then bent into shape. First, conventionally, you're going to follow the process of creating this flat pattern. Then you're going to export that flat pattern as a DXF, and then you're going to send that to your nesting software, or send it directly to your CNC machine if it does nesting. Yeah, so then we see the nesting stage where that's done, and then we see the programming setup where we set up our toolpaths for that program, whether it's done in a separate program or on a machine. So now consider what happens if we want to update this design. We have to go back to the design stage, we make that change, then we follow the same process again. We generate a flat pattern, we export that to a DXF, we send it for nesting, and then we generate the G-code. Okay, so let's look now at the fusion workflow. So what if these processes could be connected so they aren't different steps, different stages done by different departments. We want to connect all of these so that there's interchangeability, so that changes can be made quickly. Often, the later down the line of a production a change is made, the more costly it is and the more time consuming, the more time it takes up. If we can have a more efficient way of making changes later on that end up being inevitable, we want to try and avoid those, but sometimes that's not avoidable. And it allows a company to be more flexible if you can make these changes later on, if a client has a final change, or also if you're prototyping a product and you do, once you've run a short run of tests, you can see that there is a problem. It's going to be much better for you if you can more quickly make changes to that design. Okay, so a little bit about Fusion. So Fusion's base model includes design, it includes CAM, and it includes some basic nesting, but it also comes along with some extensions that can then extend the capabilities of Fusion. And most importantly, one of the biggest ones is the manufacturing extension. So this gives you access to some really powerful tools in machining. It allows you to have multi-axis machining, 4-axis rotary machining, 5-axis simultaneous machining, so you can do really complex parts in a single setup. We've got processes like a steep and shallow operation, which can do single, if you do a complex surface, you can do it with a single operation and gives you really, really good surface finish results. And included in manufacturing is also, of course, the nesting plugin, the nesting extension. Those are bundled together in this extension and add on to Fusion. And that will allow you to do powerful nesting where you can do comparative analyses of different nesting situations. You can do a nesting and you can make a change to a design, and you can quickly do a comparison of which design is giving us the best yield out of the nest. So we can have a complex design that's an assembly of different components with different thicknesses. We can set up a material store of what materials we have available, and it will automatically nest the right material, the right product, the right component on the right material. Okay, so there are further parts of the extension. We've got the simulation extension, which does finite element analysis. We can look at electronic cooling and injection molding simulation even. The design extension, that gives you more tools for, especially for injection molded plastic parts. You can do things like create hole patterns and 3D lab to reduce weight in your part. We've also got the manage extension, which allows you to implement change orders. You can do release management and automated part numbering and more control over your bill of materials. And then on the electronic side of things, we also have the signal integrity extension, where you can optimize your PCB design and you can do impedance tests on all of the components within your PCB design. Okay, so let's look at how Fusion can then connect the process of design to manufacture. Okay, so here's an example of, in the Fusion workspace, we want to say, okay, let's change the design of this part. We want to add a chamfer there instead of a roundover, and we want to see if that is going to improve our nesting. So we'll go into the design workspace. We can remove that fillet chamfer, fillet feature, and we'll change it to a chamfer. So we can quickly make that change here. We can input our value. And once it's changed in the model space, we simply go over to our sheet metal section. We'll regenerate the flat pattern that we had before. And now we see our change updated there. We finish the flat pattern, jump over to the manufacturing workspace, where we see we still have our entire model there, but now we have our nesting study created. We just have to regenerate that nesting study. And there we see the updated change already in our nested environment. And here we can see in the setup, we've already created the machining process. It was already set up to machine all of the edges of our flat design. So to make that change, all we need to do is regenerate that. Just need to reselect our nesting study. Confirm our axes. And then you see with very few clicks of a button, we've got our machining result. Okay, just let it process for a few seconds. And there we have it. We can see our blue toolpath lines and the yellow rapid lines of our machine movement. Okay, so straight from Fusion, we can then choose our CNC machine that we're working with. We can choose the right post processor to output the correct code, put in our part number, choose where it's going to be saved. And then we can have a quick visual look at our code output. Yeah, that's a quick look at the efficiency of making changes to a design and not having to go through a step-by-step process of updating the drawings, resending them to the machining department where they're gonna could even be programming it by hand, and then that's a really long process of making that change. But here with Fusion, we see we can make that change, update our nesting, update our machining information, and we can immediately generate the G code specific to our machine. Okay, so next we're going to look at some more features of the machining extension. In Fusion, it's not only limited to nesting, it also has a lot of control of apology, we're having some technical difficulties. Sorry about that. Okay, Yeah, so before we're moving on to the manufacturing workflow, yeah, so we see from that quick video how powerful that machining extension can be in, yeah, we heard that even up to 30 hours reduction in programming time. So a really powerful thing and a great investment for your workshop, especially if you are expanding and a lot of advanced machinery in your future. Okay, yeah, moving on to the manufacturing workflow. So once things have been, your programs have been, parts have been programmed, your drawings have been created for the manufacturing environment, you've set up to manufacture, what can we do there to improve those workflows to keep this connectedness going? So I'm going to hand over to Ajay now, and he's going to talk us through the manufacturing workflow.
Okay, the connected processes that are required. Now, what Autodesk actually does do quite well is to create a connected process. So the entire Fusion environment allows us to connect all the processes together into a single circular environment or ecosystem that previously used to be done in silos. Now, where you've got design and production, which Michael has quite rightly pointed out, that the design and production environments can easily be linked using Fusion itself. And then we start talking about something like Fusion Manage, which then goes into a bit more of a data analytics, or not analytics, but data connectivity process. So what the connected processes allow us to do is to have real-time data transfer where the various departments that used to work in silos are constantly in contact, which means that while you, for example, if the design team is busy designing, they can design for manufacturing. The manufacturing team can then have a look and see what the design is and if it can be manufactured. I'm sure all of you have been in a situation where the design team makes a very fancy, very beautiful design, and then it gets to the floor, and then the manufacturing operator, whether it's a CNC milling operator or a cutting operation or whatever the case may be, even these days where we've got 3D printing capabilities where you can create all kinds of fancy shapes and sizes, do have their limitations. Now, if you have a fully connected process, you can live link between all of them to just figure out what will work. And now one of the things that Michael showed us quite nicely in those videos is that you can run a simulation or a production simulation from Fusion to check that the product can be manufactured without any toolpath interruptions or any crashes or any of that sort of thing. So important thing going forward is tracking and traceability. Why do we need tracking and traceability? We'll talk about a couple of unique concepts that assist with the tracking and traceability, and why tracking and traceability is important going forward. Tracking and traceability is no longer an option because we've got to a point where we've got a lot of people who have a lot of concepts and ideas that are in limbo, so to say, where all the production and manufacturing mechanisms and methodologies have improved to a point where now the efficiency now starts to come in, where we're talking about tracking and traceability. But one very important aspect, is the compliance with regulatory standards. All of you who have had access to or have seen and worked with ISO standards, SAN standards, all of that has a large component of tracking and traceability. So if you've got a design, you need to have documentation for the design, and you need to have a full process flow track that if something does go wrong, for example, that you can actually go back, which we will talk about as we build on this particular concept. Now, regulatory standards improve manufacturing, but at the same time, it also provides for end user quality. That is one of the most important things. Now, the traceability from the manufacturer perspective allows the manufacturer themselves, as well as the standards organizations, to come and see where everything is. You can find all of your drawings, your models, your manufacturing, your posts, whatever the case may be. Then it becomes a lot easier. Now, if you have this full traceability setup, it is also a lot easier to find data when you going forward. Now, the supply chain transparency aspect of it is when you've got a fully transparent and tracked and traced situation, the ability to live link with a supplier for the supply chain so that everybody can see what is available, when it's available. If there's a lack of availability, when there's something that needs to be produced, it does need to get flagged. And that's one very important aspect of the supply chain transparency concept. But further to that, if the design team knows what needs to go into manufacturing and what the raw materials and components are going into the manufacturing, inventory control can also be dealt with. So please carry on. The next thing is the product recall efficiency. So downstream, when a product does actually go out to site, I'm sure all of you have heard about, and potentially some of us have had the unfortunate situation where a car gets recalled for, say, airbag. Now, if somebody says an airbag recall is happening, everybody gets frightened. Now, there's a cost involved to a recall, and there's also a potential hazard in terms of opening yourself up to some form of legal issues if there is a problem. Now, if that sort of problem arises, or if it does arise in one particular instance, it's much easier if you've got a fully traceable process to go and find which particular product line might be the problem and go and trace exactly where the problem came from much faster and much more efficiently, so that it avoids the amount of time that's taken place. For example, that car example that I just used now. If it's an issue with an airbag or just some sort of a connector beam or whatever the case may be, to find that particular manufacturer or the supplier that made it and then make the updates quickly, and allows you to actually reintroduce those products to market with all the corrections made, as well as it also allows you to trace the location of the error. Now, where does the error come from? It might be a perceived quality issue. It might be an actual quality issue, but it's not necessarily the case. The ability to track it and to find where the exact issue lies it reduces a lot of time, and it also reduces a lot of cost, because a recall is costly. Because now if you have to bring in a large machine and check every single one of 5,000 machines, you've got a time issue, and that actually takes time away from what should be done, i.e. production and or design. The next aspect of tracking and traceability that we need to look at is informed business decision making. Now, to have a transparent and open data flow to the management team, so that they know exactly what's happening from a manufacturing perspective, from a design perspective. What are the new products coming to market? Why are we designing this new product? All of that is something that informs management and the people who are running the departments to make decisions on any changes required, efficiency updates, additional machinery, additional training. All of that can then be informed on a much easier, as long as the documentation and the functionality is available. Then the last aspect of the tracking and tracing is the risk management factor. Now, touching on the supply chain transparency and the product recall efficiency, the risk management comes in place, where if you're tracking your process and keeping your process under control at all times, it speaks to your quality updates. It also allows you to identify potential risks going forward. Now, one of the risks could be bottlenecks. Now, one of those bottlenecks that Michael was speaking about a little bit earlier, where a machine is overloaded. Say, for example, you're sitting with a massive bottleneck of products, then it just keeps growing and growing. Now, if you have a fully tracked process flow, you can actually identify and mitigate that risk and find ways to potentially circumvent that issue, just by simply rescheduling certain tasks. That's just the one simple thing just off the top of my head that you can do to actually mitigate certain bottleneck risks. There could be a quality risk because there's not enough personnel to do a 10% quality review of 1 million components. So those are certain issues, and I'm pretty sure the airline industry issues that have happened in the recent past are something that everybody is well aware of now. This risk management, if the process was fully tracked and the quality control process was fully done, the issues that they were having currently, and if they had risk management plans in place, things would have not been as bad as they have gone. I won't be mentioning any names. Please carry on. Now, talking about tracking and traceability, we'll sort of transition nicely into the Fusion Operations software, the Autodesk Fusion Operations. This is an MES system, manufacturing execution system. What this does, carry on, we will quickly run through a short video just so that it gives you a little bit of introduction of what Fusion Operations is. Thank you. So that was the short version. So, ladies and gentlemen, what we're talking about when we take tracking and traceability, we take that one step further into the manufacturing execution system. What is a manufacturing execution system? A manufacturing execution system allows you to control your process flow. It connects with your PDM and PLM systems to grab data, and it can actually take your tasks as well. So task scheduling, it gives you a live view of what is happening on the manufacturing floor with the operators and the operational sections. Now, when we talk about taking everything to the next step, this is what we're talking about. Fusion Operations is a MES system that is predominantly cloud-based, so it's accessible anywhere from any device. It is, and I assure you, the security is not an issue at all. So when you take an MES system and apply it, it's something that allows you to do quality control as well. So we'll talk about that a little bit as well. What we're seeing here right now is a scheduling environment, essentially. So you can look at the percentage of completion Gantt chart, where if you look at the load percentage, each of the operators, each of the sections is showing what the loading capacity is and what the loading is currently. So live view, you can actually see what's happening on the production floor. So if you've got a specific operator that's being overloaded and one of them that's underutilized. So if you can just reorient or rearrange your process, for an example, you would then be able to either minimize or mitigate the bottleneck. Now, that's not spending any money at all. You've already got the operations in place. Hence, just moving the positioning of your machines can make a huge impact. But once you've got to that point, then you can start identifying the bottlenecks. You can identify which machines are being used. If you've got two operators that are doing exactly the same job, then you can set up your schedules on a live view. All right. Then the production order tracking, this is completely in the cloud. There is no paper, there is no gentleman's agreement as spoken about earlier. This is all completely controlled by the system. You can tell on live just by looking at the system from an administrative or a management perspective to see what product is being manufactured at what is being done at each of the operators and each of these. This is basically replacing the paper traveler or the job card. It is an electronic job card where you can then create the production orders, and this is all automated. It can then also link into your PLM system so that you can, like when you get the bill of materials, you link the bill of materials to the production environment. It can then go and look and see what inventory you've got and see what you need. And additionally, you can also tell it to alert you when the inventory or raw materials is running a bit short when it comes to stock. So this also speaks to a higher quality, a higher just-in-time manufacturing option, as well as leaning you towards more to the lean manufacturing process, again, saving costs, because as we all know, inventory is not profit. Inventory is cost, and inventory is money that's sitting on inventory, which is not being processed. The more you get your process flow corrected or updated or made more efficient, the more efficiently you will use materials, the more efficiently you will use processes, and the more efficiently you will use your stuff. Right. Then live dashboard analytics allows the management team, or depending on the different aspects, and just to give you a little bit of an example, there's different levels of access that you have to your manufacturing MES execution system. So you've got management access, you've got production management access, you've got producer access, you've got operator access, and so on and so forth. So that is controllable by the administration team. And from that level, whoever needs to see the data, whoever needs to report on the data will then actually be able to see this live, see how well and efficiently a process is working, how well and efficiently operators are running, up to and including the task time the time that's being used per task. Now, when you talk about task time or takt time, when you're producing a component, each different operation has an amount of time that's attached to it. So by programming that in, or you can even check to see how long it takes to produce a particular component or do a specific operation, and then you can add that to your system to say, okay, is this operation running efficiently or not, in the sense of where is this product being made slower or faster than the average or than what is selected. So as the process improves, as the operations improve, as the people improve, those times can also be made lower, and then also you can identify where certain training or additional assistance will be required on the production floor. visual process flow control, where you can tell the system, and the system will then define it in the sense in that where if you have a product that needs to be manufactured, you tell it what the operation flow has to be. So from each stage, from stage 1 to stage 2 to stage 3 to stage 4, it could be casting to machining to drilling to milling to whatever the case may be. That process flow will be designed and defined by the production management team. And when you tell the system, or when you put a object or product into production, it automatically then routes that product through the system to each required operator. Now you can also have a split operation where you've got two components being manufactured simultaneously on different operations, and you can also set that up as well. And that allows you to be more efficient, and it allows you to track the process, that if you do one thing before another, if they are interchangeable, that you can actually identify where the bottlenecks are from these outputs. These reports that are generated, you'll then see the output, the bottleneck, then you can then redefine your process. Now, one of the big wastes that we talk about is transport waste as well. So just by making the machines get closer together, you can improve the efficiency, and all of that can be live tracked in your production flow via the dashboard that you saw just now. Production scheduling, each shift changes can be, so your production schedule or your process flow schedule can then be attached to or informed by your shift variances, or your shift variances can be defined by your production flow process. So the live view scheduling aspect, as you'll see from the 10th to the 13th, you've got 5 operations. You've got pressing, 3 of them, you've got nesting. So each of those production times can be scheduled so that between X time 7 a.m. and whatever 8 a.m. or whatever the case may be, or overnight you do one particular aspect that doesn't require as much of intense work in the factory, or whatever the case may be. Now, another very interesting thing is how this speaks to sustainability. Very interesting. So back in the past, Eskom had a concept called the DSM, a demand side management, where your electricity bill was calculated based on your peak output or peak requirement, as opposed to your consistent requirement. So if you can keep your peak down, your costs go down. And at the same time, that also diminishes the requirement for load shedding, because your peaking is down. So what you'll do is you can define the startup times separately, so within 30 minutes or with a 30-minute delay, so that the machine's startup doesn't create a peak demand. So then your costs will go down, as well as the peak drain from the system. So taking all of that into account, as well as the efficiency means sustainability generally, and using the production scheduling tool, all of those other like dashboard tools, the process flow control, adding efficiency to it, removing costs, taking away the requirement for storage space, all of those things together will definitely increase the efficiency, and improve the quality as well as the throughput of your manufacturing process. We'll quickly run into a second poll, guys. We'll just, I don't know what that is.
Yeah, so we want to hear from you guys. What are the problems that you're facing with your workflow? So we're keen to get your feedback on that. We'll give you a minute or so to tell us what areas you might be facing difficulties, and if there are others not on this list, you can also drop that in the chat. Cool, thanks for your input there. All right, so then we're going to open up the floor for questions. So if you have any questions about the products we've just discussed and about the processes we were talking about, you can put those in the chat, and we will try and answer those to the best of our abilities.
Just waiting for a couple more responses, but I see at the moment the overwhelming majority is talking about scheduling. I believe that's been spoken about quite at length already when it comes to production scheduling.
Yeah. All right, thanks. Yeah, for your input there. course, no questions at the moment. Hopefully that means our presentation was very clear and answered all the questions that you had. Yeah, our call to action. Yeah, we are here to help you if you are interested in implementing these products and that they can really help out, improve your manufacturing output, if they can help you sort out those scheduling problems, help you, organizing how to maximize the time around your machine maintenance. You can contact us and we will help you on this journey of digital transformation. So we provide consulting to help you choose the right software platforms. We also provide training and we also do 3D modeling when moving over to the new software. Here are our contact details. Yes, except our Johannesburg address has changed. So contact us by phone or by email. And that is it from us. So thank you so much for your time. And we really hope that this has been beneficial. And we hope you enjoy the rest of your day.
Guys, thank you very much for listening. Have a lovely day further. And hopefully we can communicate soon.